graph number one, this absolute value expression, it's good to know what the parent function looks like. So that's like this equation here, but without any transformation. So it would just be y equals the absolute value of x. So that's going to look like a v, where each part of the v has a slope of 1 or negative 1. Alright, now these three numbers here are going to affect it in three different ways. First, anything that you subtract directly from x in the function, so in this case absolute values, sometimes it's parentheses, sometimes like a square root function, that's going to move the graph to the right. Alright, so the vertex, or your starting point, it's always going to occur at the x value that makes whatever's inside this function, whatever's inside the absolute value in this case, equal to 0. So we're going to have a vertex at the x-coordinate 7.5. So that's going to be like somewhere around here. And then, so without this part, it's just going to shift everything to the right. Not 7.5, 7 halves, so 3.5. And then, so if your vertex was here, now that plus 5 over 2 is going to move it up 5 over 2. So our vertex is going to be, so if this is y equals the absolute value of x, then without the 2, y equals the absolute value of x minus 7.5, or 7 over 2, plus 5 over 2 is going to look like this. So to the right, 3.5 up 2.5. So this could be like right here. Okay, and then I actually should have done the other transformation first, and that's the 2. So if we go back to the purple graph and we just double it, now it's going to affect the slope of these two parts so that they have a slope of 2 and negative 2, because all of these points on this line, their y-coordinates get doubled. So the distance that all these points are from the x-axis gets doubled. So that's why it gets more narrow. Alright, then if you take that and then apply these transformations, so move it 2 to the right, 3.5 to the right, up 5 over 2, then it's like you're taking that red graph and you're moving it to the right 3.5, up 5.2. It's got the same graph, the same vertex as the orange graph, just a slope of 2. Alright, so our transformations would be vertical stretch by a factor of 2, right 3.5, up 2.5. So our final answer is the graph in green. And I kind of did that in a weird order. As a good rule of thumb, you should always like do your, if it's in standard form like this, do your translations last. So first stretch it, reflect it, and then move it left, right, up, or down.